All right, guys. So this is lesson 4 of quadratics. Okay, and today's lesson will be kind of related to factored form in the sense that we're going to use factored form in order to be able to answer a question. But for the time being, this will be an opportunity for you to be able to still build upon your factoring skills. This isn't dependent on factoring skills today. Okay, it's just purely on how do we graph after we get to factored form. So you still have a couple days to figure out how to factor. Okay, so what I'll do is I'll post this, and then I'll hold office hours on Monday, and then Tuesday I'll upload another new lesson. Okay, so you have all weekend and Monday to work on this. Okay, so let's take a look here. So the goal of today is going to be able to graph quadratics written in factored form. Okay. So the success criteria with that is being able to identify the roots / zeros from a quadratic written in factored form. Okay. And then being able to find the axis of symmetry, which I'll show you how to do, and then be able to calculate and plot the vertex, which I think we did in the very first part of the course, right? Where we found, we treated it like a function machine, and we plugged in values of x, and we found out y's, and then we could plot those points, whatever those points are, right? What we're interested this time is specifically the vertex. Okay, so this time we've already seen two forms of a parabola. Okay, one is in standard form, and again, from standard form we can find the Y-intercept. Okay, and then we've also seen vertex form, and that was in the first part of the course. Okay. So from there we could find / read off the vertex. Okay. Okay. Today, in this lesson and some of last, we're going to explore why we're doing this, right? And it's called factored form, obviously. Okay. Okay, and it takes on the form y equals x minus, we'll call it s, okay, multiplied by x minus t, okay, with the caveat that x and t are just numbers. Okay, and you'll come to find that they're actually the two numbers from your man method. Okay. So we're going to take a little step back here and go back to the first part of the course, and we're going to take a look at what happens when I input values and I get outputs out. What we're going to do here, I'll do the first one, and then we'll just fill it in from there. Okay, so I'm going to plug in -3, okay, into the equation, and I'm going to get, once I do the math, after plugging in -3 into x, right, because this is telling me x is -3, so I'm going to plug it into these two spots, okay, and then I'm going to get an output out. Okay, so y equals, we're going to plug in -3 plus 1 multiplied by -3 minus 3, okay, and then we're going to get -2 multiplied by -6, which is going to equal 12, okay. So what you're going to do then is go find -3. Sorry, it's going to be 12. So you're going to go plot this point now. Right? Okay, so go plot the point, -3. I'm going to go find -3, -1, -2, -3, and then 12. And that's right there. Okay, and then you can just keep doing this, right? So if I were to plug in -2 into both those spots, right? I'll do this one just to be consistent, and then from there on I'll just fill in the rest of the table just for a sense of quickness. Okay, so you're going to plug in -2, and it's going to be -2 plus 1 multiplied by -2 minus 3, and that's going to be -1 multiplied by -5, which is going to equal to 5. Okay, so then you're going to go find -2, 5. Okay, and then if I keep doing this, I'm going to plug in -1, okay? -1 minus 1 or sorry, negative 1 plus 1 is going to be 0, right? That's 0. 0 times, over here it's going to be negative 4 is 0. Okay. And then if I plug in 0, okay, if I plug in 0, I'm going to get 0 plus 1 is going to be 1. Multiplied by 0 minus 3. Right? So that's going to be 1 multiplied by negative 3, and that's going to be that. Okay, so you plot that point. Now, I'm going to keep going. Plug in 1. When I plug in 1, I'm going to get 2 multiplied by negative 2, which is going to be negative 4. Right? And then if I plug in 2, I'm going to get 3 multiplied by negative 1. Right? And then all of a sudden, I can start seeing, I can follow a pattern, because as soon as I identify these 2 points here, they're symmetrical, we'll call it, right? Then this point here, the point in red, must be symmetrical about as well, right? So what I'm saying is, just to fast track this, is it's symmetrical about the vertex, which you remember we did in the first part of this course, right? We found the axis of symmetry, right? And then these points were symmetrical about that axis of symmetry, and that's what the purple line is, axis of symmetry. Right, so all these points from now forward, I don't need to do the rest of these. I can just plot this. So I see that the red point is 2 away from the axis of symmetry, so I can plot that there. It's 3 away here. Right, and it's going to be 4 away here. Yeah, and then you just go through here, and there's your parabola. Okay. Okay. So you could fill in the rest of this if you'd like. You could go 2 and negative 3. You could also go 3 and 0. And then 4 and 5. Okay. That's just me reading them off the table. Okay. Now, this next part here is asking me, and this is what's important. This is the most important thing here. Okay. Is locating the X-intercepts. So those are the points in which it crosses the X-axis, right? So your job is to go find those 2 points. Because it's a parabola, I see it crosses 2 points, right? So if I'm coming down, if I'm drawing the parabola, oh, across the X-axis, what value is that? Well, the value, the first value is when X equals negative 1. That's one of, we'll call it the X-intercepts. You could also exchange the word X-intercepts for roots, solutions, or zeros, okay? Any of those 4 terms mean the same thing, okay? And so there's the first one that I just identified. If I keep going, I ride the parabola and I come back, oh, I hit another one. That one occurs at X equals 3. So those are your 2 X-intercepts. Okay. Now, the other part of this question is, can you identify relative to the equation where those 2 points are, right? So that's what I'm interested in. And I can find those if I rewrite the equation that we have started with, this guy here. It's y equals x plus 1 multiplied against x minus 3. Okay? Now, I can read right from here, okay, the X-intercepts. They're just opposite to what I see here. So one of them is going to be x equals negative 1. The other one's going to be 3. And then you can just go plot those. So your points would be negative 1, 0. And the other point would be 3 and 0. Okay, you go plot those. Those are your X-intercepts. So that's how this works. Okay. So why is this true? Okay, so I'll show you a little bit of the math here. Okay, so it's why is this true? To solve for the x-intercepts, we set y is equal to 0. And to help you understand that, you could ask yourself the question, what is the y value anywhere along this, anywhere along here? Oh, I won't do that so many times. What is the y value there? Y is equal to 0. There is no height, if you will, right? So what we're doing to the equation is essentially 0 is equal to, I'll write this out as an example, plus 1 x minus 3. It's allowing us to solve, right? So what you can do is say x plus 1 is equal to 0, and x minus 3 is equal to 0. At which point you're interested in what is the value of x? X is equal to -1, or x is equal to 3, okay? That's just a long kind of fancy way of just being able to literally read them off, okay? Not that I expect you to do that every single time. This is okay, okay? Just literally being able to look at this and go, okay, here are my x-intercepts, okay? So again, on this blank here, what we want to write down is x-intercepts, roots, zeros, or you can write down x-intercepts, roots, zeros, or solutions, okay? All of those 4 terms are interchangeable and acceptable, okay? So let's do the next question. This here just wants to know, state the x-intercepts of each of the following, okay? So you're allowed to do whatever you want. If you want to say x minus 2 is equal to 0 and x plus 6 is equal to 0 and solve, I'll do it this way. Solve for x. How do I get x by itself? I add 2 to both sides, and so x is equal to positive 2, right? And then, so this one here, I could subtract 6 from both sides, right? Okay. So your x-intercepts are going to be 2, 0, and -6, 0, okay? You don't need to do that if you don't like, okay? What you can do is just fast track it, okay? So if like, I care about being able to actually produce these graphs, not get caught up in the nitty gritties of this stuff, okay? So what I want to see is, I recognize these, this is written in factored form, okay? First off, 1 written in factored form, okay? Once you recognize that, you're then free to say, okay, I know my x-intercepts are going to be x equals -3 because it's opposite to the positive 3, and x is going to be equal to 8. And so the intercepts would be 3, 0, -3, 0, sorry, and 8, 0. Okay, you can go plot those. Okay. And your last one here, this is a little bit tricky, okay? In the event that you're ever given something like this, okay? This is a little bit of a harder question. You could say, well, this is where the solving process comes into play a little bit better, right? So if ever you see an x sitting by itself, it's basically saying like this: x plus 0 is equal to 0, okay? And so therefore x is equal to 0, okay? So that one's an easy one. It's like a trivial, you can get that one right off the bat. The other one, however, is a little bit more complicated because now I have 2x minus 1 equals 0, okay? So there's no, because I've got the 2 there, I can't just say x is equal to 1. It doesn't work, okay? So this is where your solving process comes into play, and it's quite helpful, actually, right? So being able to do this, so you're just going to try and solve for x, okay? So what we're going to do is go 2x is equal to 1, and then you can divide both sides by 2. X is equal to 1/2. There are your 2 roots or solutions, okay, for this particular question. Okay. Now, I'm going to show you one more thing here, okay? And then we'll be able to actually answer some questions on our own, hopefully. Okay. So what we're going to do here is actually produce the parabola, okay? And the two, you're basically looking for 5 points, okay? 4 points even, right? We don't even need all 5. So what you can do, say, I'm looking for X-intercepts. No, okay. I'll say we're looking for X-intercepts. Okay. And that's 2 points. It's a bonus, right? And then 2, and that's using the processes we just talked about up here, okay? Nothing new there, or that's the new information. The second one we can find to help us graph is the vertex, okay, which I'll show you how to do. And the third one we can use is our Y-intercept, different from the X-intercept. And that comes from the C value in standard form. Okay. Or plug in x equals 0 into the equation, right? Just like what we did up here. If I can plug in x equals 0, right? X equals 0, spat out a -3. There's my it gave me my Y-intercept, right? So you can do that, okay? So what we're going to do here is let's find the X-intercepts from our equation, okay? So I'm going to rewrite the equation down here. Actually, I'll take this. These are your steps, okay? I'm going to move them down here, okay? And those are your steps that you need, okay? So let's do step 1. We're going to find the X-intercepts here, okay? So from our equation, you can read this right off, okay? Opposite of 1, so x is going to equal 1, and x is going to equal -5. So our X-intercepts are 1, 0, and -5, 0. So you can go plot those points, okay? So at 1, 0, you have one of the X-intercepts, and at the other one is -5, 0. Okay? Now, let's figure out, this is your step 1. You got 2 points. That's nice, right? So step 2, we said find the vertex. Okay? The vertex is a 2-parter. Okay, and I'll use Greek letters for this. I, okay? Part I is to find the middle of the X-intercepts. Okay? So basically, like, let's go to these 2 points over here, okay? And we got to find the middle. Okay, so there are 1, 2, 3, 4, 5, 6 points separating us, okay? So which means we got to get an equal number on each side. So let's go 1, 2, 3, 1, 2, 3. So what if I drew it right down the middle, right? I drew down the 1, 2, 3. Okay. So if I find the middle of the points, we know this as being something. And it is our axis of symmetry. Okay. There's also something else. It takes on a value, like we say, anywhere along this pink or magenta line, the x value is -2. Okay. So conveniently, I know that somewhere along this line, okay, somewhere along here lies the vertex. I don't know where, but somewhere along there lies our vertex, okay? And so what we're going to do here is much like what we did before. This is step 2 now. I have an input, x, okay? And it's more specifically, we have x equals 2. Sorry, x equals negative 2, okay? So what I'm going to do is input that into my equation. Okay, and what it's going to do is it's going to spit out a y on the other end, okay? And so I'm just going to do the math on this. It's negative 3 multiplied by positive 3, right? Which is going to equal negative 9. And so my vertex is, I'm going to take the negative 2 from here, because I knew it had to lie along here somewhere, okay? Negative 2, and then the negative 9 is going to come over here. And you can plot this point, negative 2, negative 9, and then we already have basically a parabola, okay? You're free to do this at this point, actually. We don't even really need the Y-intercept for this particular question. The Y-intercept provide a little bit more detail. If I wanted to find it, I could just simply go do the exact same thing I did here, except this time instead of negative 2, I would plug in 0. So 0 minus 1 multiplied by 0 plus 5. That would be negative 1 multiplied by positive 5, which would be equal to negative 5. Okay, so that would just be my we'll call this our Y-intercept. Be at 0, negative 5. So I could go up here and plot it right here. You can see we did a pretty good job of the parabola. Okay, so again, the whole point of this, and we're not heavily relying on our factoring skills yet. That's going to be probably we'll say lesson 5 will be our combining these two lessons. Okay, so you still got a bit of time to figure out factoring. So if you're trying to process this, or you're a bit behind, or you're just coming back in, I would say first step, let's master factoring. Okay, that's lesson 3. And lesson 2 as well a little bit, okay? The second thing you could polish off is, how do I produce the graph from factored form, okay? Okay, that's lesson 4. That's just what we did. Okay. Lesson 5, combining the two. Okay, so this is really, you really have to get caught up if you're behind, or we're going to be lost. Okay. All right.